Welcome to the Penn State University Head House. Today we will be talking about soil quality. So what is soil? Soil is composed of silt, sand, clay, nematodes, and humus. These components allow plants to regulate temperature, water filter, and allow them to access and store nutrients. So why is soil quality so important? It is used to sustain biological productivity. It is also used to preserve environmental quality and to promote plant and animal health and wellness within ecosystems and land use boundaries.
Soil quality plays a role in the environment, especially within the agriculture industry. Having high-quality soil produces cleaner and fresher air. So in plant terms, the soil is the base. It's where the plant grows, and that's where they anchor their roots deep into the ground. That's where the magic happens. Soil is another world where smaller organisms can live. Nematodes, earthworms, bacteria, they help nutrient cycles such as phosphorus, nitrogen, and carbon. These nutrients are the main reasons that we have basic food and necessities that are coming from plant sources. Plant uptake these nutrients, and this leads to a sustainable developmental goal.
One of the SDGs is to eradicate poverty. Maintaining productive soil gives us the chance to produce higher production rates to feed many people. This will target another SDG, which is to eradicate hunger. This is the food side of the soil. However, the other side of the soil filters the air and cleans the water, and in this case, it targets another SDG, which is a sustainable city and community.
The soil condition at the student farm at Penn State is very high quality. We tend to have nutrient-rich soils that support vegetable farming quite well. It's a Hagerstown and a no-lin type of soil. That's like the scientific term for the type of soil. Generally they're sandy and have some silt and some clay and like a nice balance of those things. They are like medium weight to them, so they're pretty easy to work. And good for vegetable growing. The main obstacles that we face at the student farm with regard to soil would be rocks. Portions of the farm have a lot of rocks and they're pretty big. So that becomes a challenge for some of our vegetable growing equipment and our tools. So we do a fair bit of rock picking to remove some of the rocks. Another challenge would be that the farm is new. A portion of the farm is new, so that soil hasn't been vegetable farmed before. So getting it up to where we want as far as texture and organic matter content can take some time to do that. Additionally, some portions of the student farm flood. There's a group of students right now, agricultural engineers, that are working on a stormwater management plan for the farm to help us mitigate some of our flooding. But there is one field that floods substantially, and that can be challenging for soil because it stays wet for a long period of time, and it can lead to soil erosion and soil compaction, both of which are challenging for vegetable farming.
Here at the Agricultural Analytical Services Laboratory, we will go over the soil quality testing process. At the beginning, all soil samples are collected and labeled to be placed in yellow containers to dry the soil using an oven at 37 degrees Celsius. The lab analysts archive samples on shelves, for which pH is measured. Thus, the process is done mechanically and manually. Other soil samples are placed into beakers to be incubated and shaken for 5 minutes, after which solution is poured into them. Finally, the lab analyst elutes the water from the samples and measures the mineral levels via absorption spectrometry. Data results from the various absorptions is recorded and analyzed. Agriculture is a human mission and our main food source on this planet. There is no life without high-quality soil.